Hi there. Today we're going to have a look at a preferential attachment model in Netlogo. Albert and Barabasi coined this term to describe a model where nodes are randomly connected, but the probability of a newly added node connecting to another node is dependent upon the number of existing connections the other node has. So what it's doing, it's adding in new nodes into the model all the time and connecting them randomly, but with a higher probability that it will connect to a node which has a pre-existing number, high number of connections, than to one where it only has one or perhaps two connections. So to run the model, we click on Setup and we click on Go. Now, as you can see in the pane on the right here, the nodes are starting to connect together, and already in the center here, we're getting some fairly highly connected hubs. If we leave this to run for a few moments, you'll see that actually a tree structure emerges with lots of branches coming off of little central hubs. And if we look at the degree distribution graph here, you'll see that there's lots of nodes with one or perhaps two connections, but there are much fewer out here at the outlier that are highly connected. Now, turn that off and click Resize Nodes. What this has done is it's highlighted the number of nodes that are heavily connected by changing the size of each node according to the number of connections it has. Preferential attachment models are very important in information terms because people tend to source information from other people who they know have that information. So it's a model that actually tends to illustrate many real-world situations where someone will ask a colleague or a co-worker who knows how to do this, and will then go to that person or go to that knowledge source. And of course, then when asked in turn, who knows how to do this or how do you do this, they will simply refer to that person or that knowledge source. So you get a very highly connected information node that services many different customers. Thank you.